All right. This is the result of our work yesterday. We saw a graph up there, and kind of looking at those and looking backwards the other way through this. Where is it undefined? Well, guys, we learned about two things being undefined yesterday. We just didn't necessarily use the word undefined, but it was those things that came from our denominator. So where is our rational function undefined? It's undefined any place that we have a hole in our graph. It's undefined any place we have a vertical asymptote in our graph. And so as we look at this picture, I know that it's a really small picture up here, so it's kind of hard to see, but you guys see the hole in the graph? There's a hole at 2. So that would be one of the places that this is undefined. There's also a vertical asymptote running right here through the x value of 1. So the other place that it would have been considered undefined would have been at x equals 1. Anytime we answer an asymptote, I don't care what type it is, vertical, horizontal, or the ones we learned today, which are slant, it has to be the equation of a line, because that's exactly what they are. They are a line. So you have to have an x equals or a y equals to start the process. It can't just be a number. That doesn't mean anything, okay? So when we're looking at this and we've got a vertical asymptote running right here, it is a vertical line. Vertical lines are of the format x equals, and it runs through the x-axis at 1. So we'd say x equals 1. Our horizontal asymptote, not as obvious because it's not drawn, but if I were to draw it in there, we can see that it is a running through at y equals, and horizontals are y equals just a number, y equals 1, okay? We will continue to practice this, like I said, but as you go, please make sure that you understand all asymptotes are equations of lines. Today, we're not really adding anything new other than the little slant. So addressing how do we find that with a little over big, big over little, or same. We didn't see the big over little yesterday. So that's our focus. That's what we're finishing up today. So these are going to look the same. We will address the domain part of it a little more today than we did yesterday because we didn't have time. Identify the vertical and horizontal asymptotes, and I would add to that our slant asymptotes today. And then graphing. So now we'll be able to graph all of our rational functions. So let's go back to yesterday. Take a second and just recap what we talked about. I have the order listed up there that we need to attack these. But ultimately, if you get off of your order, as long as you start here, the rest should not matter. But if you do not start by finding a hole first, and there is a hole, your x-intercepts and vertical asymptotes would be wrong, okay? Now we're gonna take a moment and you guys are gonna see if you could write this down. Can you write down in words the directions of how you find the x and the directions of how you find the y for a hole? And if you're realizing right now that you can't, that just means that's something that we need to keep looking back at, because you need to be able to find those. The x is usually a little bit easier than the y, but here's our directions. To find the x, that's where we're looking for something that crosses off, and what crosses off gets set equal to 0, and it ends up looking like the opposite sign always of what got crossed off, because when we solve, we use the opposite sign. It's the y that's a little trickier, but we plug in that x we just found to the, I call them leftovers. What the fraction simplified down to, we plug it in, and whatever value we get when we plug it in is the y for the whole. Moving on, after you have found that, the order does not matter. I follow the same order every time just to help myself graph it, but the order does not matter. The next thing I go to is my vertical asymptotes, and that is anything at this point that is left in your denominator set equal to 0. Remember, and then you can have 0, which would be a special case, like our special case we're going to see at the end of today, 1 or 2 or many. We typically will see 1 or 2. That thinking through the horizontal and slant asymptotes happen at the same time because it is the categorizing of our fraction little over big, big over little, or same. Yesterday we saw the horizontal, which is little over big. Automatically a horizontal asymptote of y equals 0. We saw same over same, which is also a horizontal asymptote, but unique to each fraction because it will be at y equals whatever the ratio of those leading coefficients are. And today we're adding in the last of this, and that is what we do and what it looks like when it is a big over little. Means we do not have a horizontal asymptote. We'll have what's called a slant asymptote, which sounds just like it looks. Okay. We'll talk about how to find that on the next couple of pages. Our x-intercept comes from what is in our numerator. Set equal to 0. And again, you can have multiples of those. You don't have to have one, but you can have multiples if we do. You can only have one y-intercept. Usually we have one. We don't have to, but we find it by plugging in 0. And the last reminder I'd make for you is if you have a hole in the graph, if we can cross something off, that it stays crossed off and we only use the leftovers for the entire rest of the problem to answer the rest of those spots. We glanced over domain. I know this is not on your note sheet, but you may want to jot this down somewhere. But we did glance over domain in our warm-up yesterday, and I just want to take a second and remind you, when we learned about domain restrictions, we went through the questions. Is it a fraction? Is it a radical? Is it a radical in the bottom of my fraction? And when I said it's a fraction, that I took the denominator and I set anything in the denominator not equal to 0 and solved. And I found out that x cannot equal -3 and x cannot equal +1. And then we went from -infinity to infinity and broke at each of the things that it can't equal. So -infinity up to -3, -3 up to 1, and 1 up to infinity. But what gets confusing now is that now we're talking about graphing these, and I would treat it a little different because, oh, I see something that crosses off, and when I see something that crosses off, that would be a hole in my graph, right? And what's left over, that would be a vertical asymptote, wouldn't it? Well, guys, that's what you see in your domain restrictions. You see holes, you see vertical asymptotes. We don't have to distinguish between them, and don't simplify. Go back to how you would have just found a domain, the unsimplified version. If it was ever in the denominator, it is a restriction on our domain. So you can see both of those here, right? There's the hole. Okay, and there's the vertical asymptote. And so just because it crosses off doesn't mean that it's not a domain restriction. Okay, any questions on that? All right, so let's talk about this slant asymptote. A slant asymptote, I have the book definition up there, is the long way of saying that it's a big over little. It will have a slant asymptote if the degree of the numerator is 1 more than the degree of the denominator, if it is a big over little. Then we have the directions of how to find a slant asymptote. And you find a slant asymptote by dividing the numerator by the denominator. You can do synthetic, which is the one I will do, or you can do long division. Your choice. You get the same answer at the end. So if you love long division, anyone out there love long division? Okay. If you love long division, you can use it. Synthetic division is what I will always use. It does say to ignore the remainder. Okay, so you'll see what that means in just a minute. Notice my example is slightly different than your note sheet. Let's go ahead and adjust to what I have. I have 2x squared minus 5x minus 7 over x minus 2. I just want to make sure. Ooh, change it to a plus 5. I'll match the picture on the next page here. Yep, plus 5. Okay, so first of all, we would look to factor and simplify. This one is factorable. Let's see here. Factors of 2 are 2x and x. Factors of 7 are 7 and 1. And I want a positive 5x, so a positive 7 and a negative 1. That'd give me 7 minus 2 is 5, okay? The reason I show you this, it does not simplify, does it? So it's not going to change. But when we do the divide part, for the divide part, go back to the unfactored version to think through your divide. Okay, so I'm going to go back to this. Nothing simplified. We do check that first. Nothing simplified. So as I set this up, you want to think of the unfactored version here to set up my synthetic. Don't forget to look for missing terms. We don't have any, but look for them. That when I do this, remember that we are looking at a factor down there of x minus 2. So I use the 0, 2 to divide. 2 times 2 is 4. Plus 5 is 9. 2 times 9 is what, 18, and this would be 11. And we are going to ignore the remainder. Ignore the remainder. From here, you will take this and write it as an equation. Y equals 2x plus 9. Okay, so we are looking at, remember what we're looking at? We're looking at a y equals mx plus b, where that's your y-intercept. And that's your slope and how we graph that, right? So if I were to graph this line, which we're going to on the next page, but we'll talk through it right here. If I were to graph this, I would have it crossing my x-axis at 9. And I would have a slope of, make it look like rise over run, up 2 over 1. Or if I ran out of room, which I did, I'm going to go down 2, back 1. And going to give me this straight line, but it's not going to be a solid line because we are graphing an asymptote. So my advice to you when we go to graph this is don't put dots, put dashes, and then fill in between those dashes with more dashes because we need it to be a dotted line. Okay. So let's put this into play here. I did adjust this problem, so we may have a little issue. We might need to renumber our axis here because I grabbed a new graph here, so you might need to renumber your axis on your note sheet. I did this so that we can see both types that we will end up seeing with our slant asymptote here. Okay, so first things first, we did factor this just like we did on the last page. Right? Nothing crossed off, so we don't have a hole in our graph. Following our normal order here, I do have a vertical asymptote at 2. I move on to the classification. Is it little over big, big over little, or same? We already had this conversation. It is big over little, which leads me to the fact that it has a slant asymptote, which automatically means no horizontal asymptote. So we did this work already on the last page, but to find this, we will divide and ignore the remainder. We wrote that into an equation of a line, which we got y equals 2x plus 9. We've already done all that work. Okay, so graphing this, I would graph it as a dotted line instead of like a solid with dots out there. So I'm going to go put my y-intercept up at 9, which would be, let's see, right here, with a slope of 2. So up to, mine's numbered by 2s here. So up 2 over 1, up 2 over 1, up 2 over 1. And I'm going to do that all the way across my graph here. Let's see, down 2 over 1, down 2 over 1. Until I get this dotted line all the way across my graph. Okay. How are we doing? Okay, yes. It's an asymptote. So any vertical, horizontal, or slant will all just be dotted lines. Now we move into the actual graph itself, not our asymptotes. And so our x-intercepts and y-intercepts no different. Anything currently left in our numerator, which we have 2 things, we'll get set equal to 0 to find our x-intercepts. Oops. So I would subtract 7 and divide by 2. I get -7/2 or -3.5, right? I would add 1 and I get a x-intercept at 1. So we get 2 x-intercepts here at 1 and at -3.5. plug 0 in. Because we didn't cross anything off, you have both options, the factored or the unfactored version of this, right? I'm going to go to the unfactored to plug 0 in. I get -7 over -2 or 7/2 or 3.5. And now it's just the graphing part of it. Well, guys, the rules do not change from what we did yesterday. So I have a vertical asymptote 1. It splits my graph into 2 parts. It splits my graph into a right side and it splits my graph into a left side. And if I cover up, just to kind of make our point here, one side at a time, and I just look at the left side, I have dots, don't I? So I clearly can graph. We do just like we did yesterday, as I'm going to follow my asymptotes, but this time it's kind of a slanty one. Follow, go through my dots, and then slide along my vertical asymptote. But if I look at the other side, the right-hand side, I do not have any dots, do I? And so that's where I have to plug in something, 3 or 4 or 5. I'm going to pick 3. I'm going to go back to, again, to the unfactored version. So 2 times 3 squared plus 5 times 3 minus 7 over 3 minus 2. All right, oh, what do we get there in the top? 3 squared is 9 times 2 is 18 plus 8 more, 26. Somebody check my math there, 26. Perfect, okay. So we're at 3 up at 26. And again, that just tells me what section it's going to be in, and I can now just follow. So I'm going to follow my vertical asymptotes. I'm going to come to my next asymptote, turn around, and it's a slant one, so I'm going to follow it. If I were to continue to extend that slant, it's going this way, so I'm just following along that slant asymptote. We are going to see one of 2 shapes. I would call this one kind of your like parabola shape, where it's kind of like a squished parabola, okay? That's one of 2 shapes that we will see. On the next example, we will see the other option. And the other option is more like a elongated corner, okay? And if it's not one of those 2 shapes, something went wrong. All right, are we ready for the last example of slant asymptotes? Maybe, there we go. Function, x squared minus 4x minus 5 over x minus 3. Okay, we're going to start with our factoring to see if we have a hole in this graph. Hole? No, nothing crosses off, right? Vertical asymptote. Yes, we have something in our denominator. Has to be the equation line. It's not just a number. So we're going to have a vertical asymptote over at x equals 3. Then we do the whole little over big, big over little, or same. Think about the unfactored version. X squared over an x to the first makes it a big over little. That leads us to our slant. So we do not have a horizontal asymptote. You cannot have both. Okay, let's do our divide real quick and then we will head. So 1, -4, -5. We are dividing by 3. And we don't care what the remainder is because we ignore that. Transition that 1 and -1 into an equation, y equals 1x minus 1. And I think we'll pick up with graphing that when we come back from lunch.